Good morning, everyone.
Hey,
Welcome to another Festo Connect and Learn session. Hey, Alejandro, how are you doing?
hey, how are you, Sandro? Pretty good. Very
Yeah, yeah,
excited about today. Nice
yeah,
day.
yeah. Actually,
Summer.
I'm really excited. This is one of my favorite topics of all times, I think.
Of course.
So it's a really interesting topic that we're going to be covering the next 30 minutes or so.
Yeah,
Um,
very nice to see a lot of people connected right now. That's
Yeah,
beautiful.
yeah, we have some people. We have people from South Africa. We have people from, I believe, England. We have people
hmm
from the US, of course, Canada, Mexico.
Yeah, just type
So,
type your type your country so we can take a look and see where you guys from. I'm actually located in Toronto, Sandro. You're
yeah,
in US and
yeah,
Chicago. Yeah,
I'm
that's
based in
good.
Chicago. Yeah, yeah,
That's good.
and yeah, okay. Well,
All right.
welcome to another session. I'm sorry today I have a different kind of like a different layout. I have my screen here on the left, so you're gonna see me turning on to this side a lot. But just quick introduction and reminders. Please remember that this is your time. I mean, we're putting this together. This is not your usual webinar where Alejandro and myself were just talking and talking and talking and boring you to death. This is actually
Yeah,
your time. This is a space for you to ask questions, to unmute yourself, to type it in the chat. Um, and if for whatever reason you're
that's very
shy or
informal.
yeah, it's very informal. It's like grabbing a coffee with a friend, so you can really ask questions. This is your
hmm
time. We support questions in English, Spanish, and French. So if you
Correct.
feel more comfortable typing your question in Spanish, si te sientes más cómodo poniendo tu pregunta en español, puedes
hmm
hacerlo en el chat o puedes
hmm
hacerlo en el micrófono también.
Exactement.
So French, Alejandro?
Pour les gens qui nous rejoignent en français, vous êtes bienvenus à nous envoyer vos questions. On va pouvoir vous répondre. Puis aussi, sinon, on va vous montrer aussi nos adresses de courriel. Comme ça, vous pouvez connecter avec nous.
Perfect. Awesome. So whatever he said, I agree. Today's topic is going to be PLC programming. Of
Mhm.
course, keep in mind that this is a super broad topic. We're, of course, never going to be able to cover it in 30 minutes, but at least you're going to get something out of this session, okay?
Some of
So
flavor. Mhm.
yeah, something at least. We're gonna be focusing heavily on codices because that's usually what we deal the most of the time. But we can also talk a little bit about other platforms, you know, like Siemens or
Yeah,
Rockwell, even Omron, some
yeah.
other platforms that you might have come into interacting with
Yeah.
before. And the one last slide that I'm going to show for today is this one, in which I want to remind you, these sessions are being recorded and they are posted later on YouTube. So feel free, if you have a question, you can type in your question, suggestion, or whatever on the YouTube comments, or you can always reach out to us via email.
Yeah,
There's our email, so you
exactly.
can also send us an email with any questions. Alejandro, before we start, anything else that you want to touch on?
No, basically that's all what you mentioned. It's nice to talk about this. I'm a controls engineer. That's a good topic for me. Is very excited to see how many people we have connected. The other thing I like to mention is, as Sandro mentioned earlier, is the integration with different platforms. So we're fully familiar with Siemens, Rockwell, Omron, Beckhoff. So if you have any concern, any question that you feel that is important for us to know, and let feel free, and we can actually know both sides of the world, and we can tell you, okay, well, this can be done in CODESYS, but this can also be done in this platform that you're familiar with, and you can kind of understand what the differences are.
Right, right.
Mhm.
Okay, awesome. So, Alejandro, I think you have something to share. I'm going to stop sharing now.
Yes,
So
yeah.
now you
Let
can
me
go
just
ahead.
share my screen. 1 second. So the first thing I wanted to share with you guys is let's take a look at what is exactly CODESYS itself, and how or what is exactly when you look at CODESYS. So right now, what you can see here, this program is being done in the CODESYS platform. CODESYS is basically a programming environment. Uh, in my words, it's just an application software that you can develop pretty much whatever you like. I mean, you can be very basic on developing code in text, but you can also be very familiar with ladder logic, graph set, function blocks, and pretty much any type of programming languages. So Sandro, we normally cover up to 6 different methods to program, and we can also have oriented programming in this platform. So it can be very simple in terms of programming, like creating a Boolean and double integer and so on. And it can be also be very complex in terms of creating functions and particular object-oriented programming environment. So the other thing I like about CODESYS itself is that you can combine standard programming. So if you look at here, I have a bunch of folders, and in every folder I have multiple programs. I can organize my program any way I want. On top of that, you can have all the communication links down here. So I have an EtherCAT. In this case, I have an EtherCAT master. So I also have a soft motion. I also have Profinet. So the good thing about CODESYS is allows you to connect with multiple platforms and integrate. Also, one nice thing about it is visualizations. So
yeah. Well, Alejandro, let me stop you right there, because you mentioned
Yep.
one key thing that's usually a hot topic when you're talking with programmers, and that is the different methods of programming, right? You have the most common one is ladder logic. Whenever you talk to like a technician or a controls engineer, everyone knows ladder logic. There's also structured text and some other ones, right? One thing that I wanted to mention here is that there is no one language that is the perfect for every single application. Usually a programmer, the best way to approach is a program is to use the different languages. Each language has its benefits. So usually when I program, I use, for example, a lot of the programming is done in structured text, which is just code. Alejandro can probably show you there an example. But once I do that, then I have some other things that are called continuous function chart, which is function blocks. So with function blocks, I can easily display what's going on in the program without the programmer having to go into the structured text. So just wanted to throw that out there.
Yeah, that's a nice point, Sandro. The good thing about this is, as you mentioned, we can combine multiple type of programming. So you can see in my screen, we have just ladder logic with a contact, normally open contact, T on or timer on, and so on. And we can also have different type of programming like just text, or this is similar, instruction list. This is very similar to Siemens for people that are familiar with Siemens. So that allows you to kind of understand, okay, what is the difference between ladder logic and text? The nice thing about this is we're using the software that is provided by Festo, but the CODESYS is really a 3S company that can have multiple controllers in the market. So Festo is taking those chips from CODESYS and installing that in our own controllers. So I can give you an example. Let me just remove my background here, because that's gonna probably cause some issues. But I want to show you exactly what this means.
Yeah, well, Alejandro is getting prepared there. One thing that you probably saw somewhere in CODESYS, or maybe in the industry, is the term IEC 61131. 61131-3 actually, that defines some standards in terms of programming, like, okay, ladder logic, it's supposed to look like this, structured text, it's supposed to look like this, and so on, right? So the nice thing about that is that if you are using a programming environment that's compliant with 61131, that means if you know how to use CODESYS, you know how to use this other programming environment, and you know how to use this other thing. Yes, one of them, a couple of the things that might change is, oh, where is this thing in the menu? But that's about it, right?
Yeah. Just to mention on that, Sandro, while I'm showing the controller, maybe you can go and search on the Google website and find out Festo support and get the link. We can post it on the chat. You can get the link, and on that link, you can download the CODESYS provided by Festo, and you can do pretty much all what we're going to show you. One of the nice things about what I was talking about here is this. If you guys can see, there is a little label down here. You guys see this? This little label here it says CODESYS. That means this controller from Festo has a chip inside that is provided by CODESYS. And we have different form factors, same way on this one, CODESYS. So when we buy a controller based on CODESYS, that means that little chip is inside, and any program that you do based on CODESYS for Waggle, for Parker, or any other in the market will be also compatible with this controller. You only need to change a couple things in terms of the processor and the hardware itself, because one of the nice things about CODESYS is this is called target specific. Target specific means that you have to decide what kind of PLC you're going to use in order to develop your code, but you can change that at any time. The other thing is, CODESYS is a very powerful structure, because it's allowing you to combine visualizations, programming, ladder, function blocks, stacks, anything, and also allows you to combine motion control and communication. So you can basically test anything you want in this virtual environment without having a controller. So what Sandro is going to show us in a minute is we have a physical hardware that you guys can see on the screen in one of the videos. We have a PLC, which is similar to this one, but at any time we can just convert that processor to be virtual. Then we can just run the code without even having the controller connected. Right. So Sandro, you want to share your?
Yeah, let me. Well, by the way, I just put the link there. So if you're feeling adventurous and you want to download CODESYS and play a little bit with it, feel free to do that. I just put the link there on the chat. I'm going to spotlight this video so you can check something out. I'm going to explain something quickly here. So what I have here today for hardware, let me see if it doesn't get all the way. Okay, so here we go. This is the actual controller. This is the PLC right here. So this is the controller that Alejandro was talking about. This is the PLC. This is think about it as a computer, right? That's the thing that you program. I can actually, in this particular case, I can actually split this if I wanted to. I mean, I can. There are some clips on the bottom that I can undo, and I can split this and have these separate. So these are I/O modules, right? And I'm going to explain what these are in just a second. What else do we have in a controller, in a PLC? Well, usually you have some communication ports, right? In this case, you see this cable here. This cable is going to my computer because right now I'm connected. I'm online with the controller because I was doing a program earlier. This is going to my computer. This other cable, this other port here, the second one, this is a port that is also internally connected to the first one. So now I can do some like a rung topology, right? So I can connect another device. Then the one on the bottom, this is EtherCAT, and this is where I wanted to spend a little bit of time. This is EtherCAT, and the reason why we have EtherCAT is because we can now control some other EtherCAT devices. Now, I'm also gonna touch on a very important topic, which is usually something that I see a lot of people being confused about, and that is Ethernet communications, right? A lot of the times people say, and for example, we have customers that say, oh, I need this with Ethernet. And we're like, what kind of Ethernet? Because there are different flavors of Ethernet, right? So there's Ethernet IP, there's EtherCAT. Profinet, for example, is another protocol that runs on Ethernet. So make sure that every time that you're talking about communications and someone says Ethernet, ask about what kind of Ethernet, which flavor of Ethernet. There's also Modbus TCP. There's different things that run on Ethernet, okay? Anyways, what else do we have? Just a USB port. I'm not gonna spend a lot of time on this portion over here. The one thing that I wanted to mention here on the left, you also see two additional ports. Alejandro mentioned this at the very beginning, but maybe you missed it. Why do we have more ports on the left? The reason is because this particular controller, this is a Profinet slave, meaning that if I had a Profinet master, like let's say a PLC from Siemens, I could have this PLC, this one, as a slave, following instructions from the master PLC. Okay, that's
Yep.
why I have these ports here on the left. And
Yep.
that's about it for the controller.
Let's move on to the code so we can
Yeah.
take a look at the programming environment, and I can also share a little bit on my side in a bit.
Okay, all right.
Any questions so far, guys? I think we're going too much on the hardware. Let's go more in the software.
Yeah, sure. Let's do that now. Okay, so what about the code? Let's take a look here.
Can you open the ladder program? Do you have a ladder program?
Oh,
somewhere?
I do not have a ladder.
Okay,
I can. Yeah, you can show it. And while you show it, I can also write something quickly. So what do I have here? I'm actually online right now. Let me get offline. So what I have here is it's a very easy program that basically what it's doing, it's just moving this actuator from left to right. This one over here. Okay. Mm-hmm. How does it work? Usually in any programming environment, you have to declare variables that you're going to be using, right? There are different multiple types of variables. For example, a Boolean, which is on and off, or true and false. There's numeric values and so on. So the couple of things that I have here is I'm declaring these values on the very top. So I'm saying, okay, this variable, for example, is located at a specific address. Right?
Like a mapping.
Yes,
yeah,
you're
mapping.
Yes,
mapping
you're mapping the addresses.
And the software.
Exactly, because the controller doesn't know what X extend means, right? So what I'm telling it on this particular line is I'm telling it X extend, it's gonna be, let's say, at output 0. That's what's happening. And that's what I'm doing with the rest of the variables there. Now, maybe at this point you're wondering, why is it called X extend and X retract and X reset error? That's because we use a naming convention that's shown here.
That's important too.
Yeah, there's a naming convention, and you don't really, I mean, many programmers, maybe they don't follow this, but it's really recommended because then it's easy to troubleshoot issues later on.
And understand code from somebody else also.
Exactly, exactly. As a programmer, I think that the best thing that you can do is try, whenever you're programming something, think about whoever is going to see your code later on. It doesn't matter that you understand it. You're not going to be 24/7 next to the machine, right? So here I have, you can see I'm not going to go through all of them, but I can explain the first one at least, Boolean. So it says, if you have a variable of type Boolean, you always use the prefix X and then the variable name, right? So in my case, if I go back here, you can see that what I used is X extend because this is of type Boolean. Right? Yeah. And that's exactly the same thing that I did with the rest, with the exception of this one over here. This one I called step auto. Actually, I got it wrong here. I should call it I step auto because this is of type integer, right? And that's it in terms of variables.
One nice thing about this also is you can kind of disconnect that physical hardware that is called the QX or the physical output from the variable just by putting in between brackets the portion that is referring to the physical output. So Sandro, if let's say I want to disconnect a physical output or change the mapping, that can be easily done by just changing this code. The other thing about this environment is, if you go somewhere else in the program and you are calling that variable that is called X extend, the nice thing about having the X at the beginning is because it's going to tell you that that's a Boolean, and you know how to treat that variable. It's a Boolean, then you cannot assign double integers into that and so on.
Right.
Go ahead,
right.
Sandro.
Yeah, so what Alejandro was saying is that maybe if I wanted to disconnect this from the actual hardware, what I could do is just put this between parentheses like this. So what I'm doing is I'm telling the controller X extend exists, is in the program, but it's not linked to any physical inputs and outputs, right?
Exactly.
I can comment the mapping.
Yeah.
Anyways, let's
take a look at the code.
Yeah, let's take a look at the code. There's not a lot of things that we can cover in such a short period of time, but this is super simple, and I want to show you how easy it is to move an actuator back and forth, okay? What I'm using here, it's a couple of instructions. For example, the very first one is a case statement, right? A case
statement. Just to create a step by step. pretty much. It's the
Exactly.
way that you create step by step in text.
Exactly. A case statement, it's the only thing that it's doing is checking for what's the value of iStep auto. And if it's saying, in case that iStep auto is 0, then do this. In case that iStep auto is 10, then do this, right? That's basically what it is doing. So that's the case statement. Then the if, what I'm doing here is, as the name says it, it says if this is true, if you have this value, this variable is true, then do this, right? So if you take a look at my code here, what I'm doing is I tell it, okay, iStep auto starts at 0, right? Every time that I start my PLC, I tell it if in the case of iStep auto 0, then if you see the start manual, then move a 10 or assign a 10 to iStep auto. What happens is that now iStep auto has a value of 10 and it goes to the next step. This is super easy to troubleshoot a process later on, because now you can see if something is stuck. Now you can go into that particular case and see, oh, this is where it's stuck, right?
Yeah.
So what is happening?
Sandro, yeah, go ahead. No, I just want to let you know that we don't have a lot of time, so do you want to go online and run it and see?
Yeah, sure. So I'm
I
gonna
also want to show the latter portion of it, if you have a chance.
So I'm gonna connect now, and let's see. I did some changes, so I'm just gonna say okay. Here, what I'm doing is I'm just gonna say when you go to step 10, retract. So you can see here I set it to true. And then I ask it, if you're retracted, then move to the next step. And that's exactly the same thing that I'm doing on the other steps. Now, you're still looking at the hardware, right? I think?
Yes.
Yeah, okay. So I'm going to enable this start manual here. So you see the current value is false. I'm gonna make it true. So I'm going to write the values, and you can see the actuator here. It's moving now back and forth because it's just doing this code. And you can see in just a few lines of code, I'm able to make this move back and forth, and that's it.
Yeah.
Okay.
Yeah, that's pretty simple.
One thing that before we jump into your presentation, Alejandro, one thing that Alejandro mentioned is visualizations. So in CODESYS, you can also create visualizations like this one, where I just link this graph to that start signal, start variable. So every time that I click on this start button, like that, I just click on my computer, start button, the actuator is gonna move back and forth. So this is really cool for whenever you have a certain section in the machine where you want to visualize stuff, you can do it like this in CODESYS.
And I'm gonna show you a more complex visualization in a minute. So let me share my screen.
Yeah, go ahead.
So I'm running in a virtual machine right now. So this virtual machine is in my computer, but I also have a remote machine that I'm going to show you if we have enough time, or you guys want to stay for a little bit longer. This code here is now way more complex, and I'm going to show you the complexity on just ladder logic, where here we have just basic logic with contacts, okay, like on, off, if it's this, and then do this. And it's pretty similar to any other platform that is in the market. The other thing nice about this is you can combine multiple other programs same way. This one, for example, is also a ladder, but here I'm controlling a pump with a function block. So this function block allows me to just generate a pump control. I also have another program here that is very simple, as Sandro was mentioning, just a bunch of timers and some hardware connected. Another thing that I like a lot about this is you guys that are online right now with us, you can download the program that we just posted. Once you install everything, because you don't have the hardware probably, if you want to run the code, you can click here in online, you can click simulation, and now you can run the whole code without having a PLC.
Yeah, this is a big thing. Like really, you cannot imagine how big this is, because usually I get this question also a lot from college students, for example, they are in the engineering, getting their engineering degree, and they say, "Hey, I want to learn more about PLCs, but I don't have a PLC. It's expensive, and it's like $2,000 or whatever it is."
Exactly.
And I tell them, download CODESYS, practice there. Also, you can type in CODESYS in YouTube and you're going to find a bunch of different tutorials there. So
Yeah.
it's easy to use and it's super, super helpful for the professional world.
Yeah, as I mentioned earlier, this is a simulation. So in this case, I can run my code and I can, change contacts, like change for normally open, normally close. I also have some timers down here. Let me show you real quick. So if I want to do a debounce timer, I can just configure an array, which is nice. I like a lot about this because it's super simple to create arrays. Arrays is a nice way to program because it simplifies too much the way that you create multiple things. So for instance, if I go right now, if I want to declare a timer, normally you have to go one by one. But in my case, I can configure my program to have an array of 70 timers. So I'm running right now with 70 multiple timers, and every timer has a different setup and all the configuration here. How I do that is super simple. I can just log out and I can just configure this way. Create an array of a T on, which is a timer on. The other nice thing about this is something called DUTs. So the DUT is basically um, uh, your own tag, if you put it this way. I'm going to explain very, very basic. Let's say I want to call these an analog signal type. Instead of being Boolean, it's going to be analog signal. And inside that analog signal, I created a bunch of multiple tags: Boolean, real, word, any. And I can also configure a way more complex tags where I have a bunch of Booleans and other type of tags. So that allows me to, when I call, let's say, this program here, okay, and I create a tag. Let me just go online quickly. So let me go scroll up here. Yeah, here we have, let's say here, I have the same tag that is being called XVMF pump, can be triggered from multiple ways. One is when it's in auto mode, or if I have an HMI, I can also call this HMI, or I can call from the Modbus stack. So that is super powerful because you can run code in your PC without having even any hardware. So there is no reason to say, hey, I cannot learn how to program or how be very good in coding because I don't have a PLC. But in this case, is not true. So I can. That's definitely an option for learning. Let me take a look at the chat. Sandro, do you see
I
a
was
question?
just asking people like if you have any questions because
Yeah.
Alejandro can go really in depth into the details. This, of course, is not a CODESYS class. We just wanted to give you a sense of what it is, what is programming, how does it look like, a couple of terminology that you might hear out there as well. Of course, if we had more time, we will spend more time into the details and making examples and exercises and so on. Any questions that anyone might have, usually what I do during my trainings is I say, there's no stupid questions. I really prefer that people ask questions than just hold their question inside and not ask them, and then they never know the answer. There's a question. I have one question related to data assignation to real register in PLC. If I declare a variable as retainer persistent, okay. I have one question related to data assignation to real register in PLC. If I declare a variable as retainer persistent, so what is the question? Do I need to address that to a memory space?
No, that is actually automatically managed by CODESYS. So as soon as you, let me go back to my program, okay, and I'll show you real quick how it can be done. So let's say in my program, let me just create a text one. Let's take a look at this text. So let's say my variable. So I'm just going to type it. Be my Boolean, okay, equal to whatever, 1, okay? Now here, CODESYS is telling me how you want to manage this variable. Is that a retain? Yes. Is that persistent? Yes. And then you have any initialization value. Let's say I want, as soon as the PLC power on, I want to be this value true, or I want to be false. So because it's a Boolean, so I'm gonna say I want this to be true or just 1. And then, do you have a link to this as a variable to a physical address? Then you can mention that. And the other thing is you can select these as a variable global, okay? And you're gonna create a new object, for example, if you want. Or you can just leave it as default, okay?
Right.
Variable, and that's it. So what's gonna happen here is, let me just show you back to your question, is as soon as you declare this, and you tell the system that is a retained persistent, it's automatically taking care of all the memory, where it's going to be located, and what is necessary in terms of resources.
Let me back up just for the people that might not be very familiar with this concept. The concept of the retained persistent means when you power off the PLC, the controller, let's say you switch off the machine, right? What do you want to happen to the values of that variable? So let's say that the machine was working, you're filling a tank with a certain liquid, and there was a value of 100. So what happens if you power down the machine? Do you want that value of 100 to remain after you power on the machine, or do you want that value of 100 to go back to 0 and reset? If you declare the variable as retained persistent, like Alejandro just explained right now, the controller is gonna make it persistent. It's gonna keep that value of 100.
There's a flash memory.
Yes, in a persistent memory inside of the controller. Marcus mentioned, why don't you create a CODESYS class? It's nice to see new ways of doing stuff. We sometimes do internal CODESYS classes, but I think it would be a little bit of a challenge to do an online. Maybe we could do it.
Try.
We could try. We can do a series of classes. Yeah. Trevor asks a question. Sandro, back when you had your program open in the declare variable window, what did the numbers signify before Boolean? In other words, x extend and then percentage 0.0 bool. In that case, what does the percentage 0.0 means? That, Trevor, means that I'm linking that to a specific address. So I'm actually
I can share here if you want. Yeah,
okay.
I can share that. So for instance, here, if we go back to my program, you guys can see probably this area here. I have a CPX system, let's say like a program tree. Inside the program tree, I have a PLC tree where I have a bunch of inputs. So for instance, I'm gonna enable this. This is an 8 digital input, the 8 digital outputs. Inside the 8 digital output, there is a mapping that is coming already pre-configured in CODESYS. And that's what Sandro was configuring earlier. So percentage UX 16.0, that's a physical output. So every time you trigger that, it's gonna go out and generate a signal to 24 volts and so on.
Yeah.
I'm clear.
Yeah, just to show it with the actual example that we had earlier. So x extend, it's saying percentage QX 10.0. Where is this QX 10.0? If I go back to my to what Alejandro was saying, it's a specific module inside of the controller. So it's actually this module here, and it's telling it inside of that module there's a couple of addresses, and you can see here address QX 10.0. So I'm just linking the software to the hardware. That's what's happening, right?
Yeah. There's another question about clear all when you add a new retained persistent. Yes. The reason why you need to do that is because the PLC internally is creating a stack of memory allocated for retained persistent. What's going to happen is every time you add multiple values, or multiple tags, it needs to be read-write inside. It's not necessarily done all the time, or it is not necessarily to be done all the time, but it's recommended because it's going to flush all that flash memory and rewrite the entire persistent and retained memory. And that's the reason why. Yeah.
Right. So we're out of time, unfortunately. Actually, we're 4 minutes over. Usually want to keep it short. But hopefully you were able to get at least a little taste about what CODESYS is, what a PLC is, what communications and all of that.
So it's a broad
It's
It's a very
super broad.
broad.
It's super broad. I mean, I've been dealing with CODESYS for the last 10 years, and I every day I find out new things.
Yeah.
But I really recommend, like, if you're into programming, if you want to learn something new, YouTube, it's a great resource.
Yeah.
There's a few channels out there that they have several sessions.
And
Yeah.
you know what is a nice suggestion? I mean, if you guys want us to do a basic programming, course, and we can do it online, we can spend an hour and just do it, right? It's a super simple, and we can all run virtual code, which is nice. You don't have to have a hardware for that. We can maybe plan for that. One of the Connect and Learn
Yeah, man, maybe.
extended version, like bonus
I'm
track.
yeah, I'm getting convinced now. I'm being convinced.
That's a
So
Connect and
anyway,
Learn bonus.
yeah. Anyways, well, thank you all for joining. It was really great to spend some time with everyone online. I'm really glad to see a lot of people online right now.
Yeah, that's
We have
nice.
people,
Merci tout le
yeah,
monde. Gracias
yeah.
a
We
todos
have
por estar
people
conectados.
from again from Canada, Texas, New York, South Africa, I think England as
Mexico.
well, Mexico. So
Yeah,
thank
that's
you all for
nice.
your time. And
Thank you, guys.
if you have any topic that you wanna see on a future session, let us know. Actually, I also missed a person here. There's a person also from Vietnam, so that's really great to see some
Oh
other
yeah, yeah,
people.
yeah, yeah.
Yeah. So
Hang on,
thanks for joining, and please suggest any topic that you're interested in. We can always prepare the topic. If Alejandro and myself, if we don't know, we're gonna bring a guest speaker that knows and it's the expert in the topic. Also, check out the previous sessions that we've had in YouTube. You can always watch those it's on Festo US. Just type Festo US and it's Festo Connect and Learn. So you're gonna see them there. Again, thank you all. Thanks for joining, and we'll be
Yep,
talking to you.
yep. Okay, guys. Bye. See you, Sandro.
See you, Alejandro. Bye bye.
Bye, guys. Thank you.